What if I told you that some of the largest structures in our universe are actually invisible? Right now, astronomers are grappling with a discovery that defies our current understanding of how galaxies are even formed. We have found a ghost galaxy named Nube, and it's changing everything. Located about 300 million lights year away, Nube, which is Spanish name for cloud, is a massive ultra-diffuse galaxy. But here is the catch. It is almost entirely dark. While it is roughly one-third of the size of our Milky Way, it has the star density of a tiny galaxy. In fact, it's about 10 times fainter than other galaxies of its type. It is so spread out and so dim that it's essentially a cosmic phantom, hidden in plain sight until our most advanced imaging techniques pulled it from the shadows. What makes Nube truly mind-blending is its composition. Research indicates that this galaxy is roughly 99% dark matter. We have known for a long time that dark matter acts as the cosmic glue that holds galaxies together. But Nube is an extreme outlier. In most galaxies, stars and gas provide a visible framework. But here, the dark matter is doing all the heavy lifting, with almost no visible stuff to show for it. This discovery poses a massive problem of our current cosmological models. According to the cold dark matter theory, the leading explanation for how the universe evolved, a galaxy with this much mass should have a much denser core of stars. Nube shouldn't be this spread out. It should be concentrated. The fact that it exists suggests that dark matter might not behave exactly the way we thought. It challenges the idea that dark matter is cloud and suggests it might have properties that allow it to push back against gravity on a small scale. But Nube isn't the only thing rewriting the history books. Thanks to the James Webb Space Telescope and its first deep field, we are seeing the invisible in other ways. By using a phenomenon called gravitational lensing, where the mass of a foreground galaxy cluster bends the light of objects behind it. Webb has allowed us to see galaxies that existed over 13 billion years ago. We are looking at the very first flickers of the light in the universe. When we combine the data from these deep field observations with the discoveries of dark galaxies like Nube, we are realizing we have only been seeing a fraction of the story. Hubble and Webb are showing us that the universe is far more ghostly than we imagine. We are finding that the darkest galaxies might actually hold the key to understanding the invisible 85% of the universe mass. We used to think the universe was defined by the stars we could see. Now we are realizing the stars are just the foam on the top of a vast dark ocean. If a galaxy like Nube can exist, a massive invisible cloud of dark matter holding onto a handful of lonely stars, what else is out there in the void that we simply haven't learned how to see yet? We are no longer just mapping the light, we are now finally beginning to map the darkness.